Hey there, I'm Jennifer Pulley, and welcome to another episode of NASA 360. We have a great show lined up for you today. First, we're going to talk about NASA's exploration plans. You know, like, where are they headed? Try the moon. We're going back. And Mars. Then, for all you gearheads out there, we're going to show you how IndyCar and NASCAR are using some NASA technologies in racing. But first, let's talk about this behind me. By the end of the next decade, NASA is planning on going back to the moon. Now, technology, it has changed so much since 1969, when they originally landed on the moon. So, NASA's been developing new technologies, new spacecraft, new structures to help them get back. And with any new plan like this, huge concern, safety. And it should be. With that being said, NASA has begun testing the new concepts and vehicles to help them get back to the moon. And this thing behind me, it's part of the testing. It's called the Flight Test Article for the Launch Abort System. What does that mean? Let me help you break it down. The vehicles that NASA will be using in their new exploration plans will look very similar to the Apollo vehicles used back in the 1960s and 70s, but these will be much more advanced. NASA's new spacecraft will include the Ares rocket that will carry crew and cargo into space, the Altair lunar lander that will bring crews down to the lunar surface. And finally, there will be the Orion capsule that will house NASA astronauts during liftoff and return to Earth. So, you see, this flight test article is a mock-up of that Orion capsule I was just talking about. Yeah, but why would NASA need a mock-up like this? In the unlikely event that the astronauts need to escape from the launch pad quickly, the launch abort system will lift the Orion capsule away from the danger area, 1 mile in the air and 1 mile downrange. Parachutes will deploy, and the capsule will come down for a landing. So before astronauts fly in this capsule, NASA must test it to be sure it operates properly and that it's safe. That's where the flight test article comes in. NASA can't rely on computer simulations alone. So they need to test a full-scale unmanned version of the craft. It will be strapped onto the escape rocket motor and fired to make sure that everything works as planned. The results of this test will help NASA make sure everything is in working order and give some reassurance that this system will keep the crews safe. By now, if you didn't already know it before, you've heard me say NASA first went to the moon back in 1969. But did you know that tons of the materials developed for those first moon missions can be found in our daily lives? That's right. You can find some NASA-inspired technologies in your home, your car, your computer, even in the packaging for the food we eat. And guess where else they can be found? Try professional sports equipment. There's not a sport around that hasn't been touched by NASA in some way. Now, to help show us that NASA technology, Johnny Alonso cruised down to Miami, Florida to meet with some folks from the IndyCar series.
How's it going? Johnny Alonso. Let me ask you something. If you had to guess, what would you say is the most popular spectator sport in the world? Football? Soccer? Basketball? Yeah, those are all popular, but one that doesn't come to mind as quickly is auto racing. Hands down, auto racing's in the top tier of sporting events, and just to prove that, all you gotta do is check out the numbers. You know the Indianapolis Motor Speedway that hosts the Indy 500? That place can almost seat 400,000 people, and that's just for one race. One race! From the first cars ever built through today, people have always wanted to see cars go faster and faster. But let me tell you, by today's standards, those early cars weren't exactly what you would call safe. A lot of drivers didn't wear seatbelts or helmets, and actually many of the cars didn't even have padded seats. So things could get sketchy really fast in the old days. But today's racing is very different. Although it's still fraught with risks, the technology and engineering that goes into the sport is amazing. Without doubt, racing is one of the most advanced and technology-driven sports around. Okay, so what does NASA have to do with racing? Well, a lot more than you might think. Dozens of NASA-inspired technologies that were originally created for space and aeronautics are now being used in race cars. So to find out more about these NASA-inspired technologies, I traveled down to the Homestead Miami Raceway to speak with some key people from IndyCar. Even if you don't know anything about racing, you know what an IndyCar is. These super sleek race cars can put out over 700 horsepower and can reach speeds well over 200 miles per hour.
The IndyCar Series is the premier open-wheeled racing league in the country. Now, open-wheel is different from, say, NASCAR, because the steering wheel is outside the main body, not tucked under a roof.
So a lot of testing goes into every car, and one of the key elements that are being tested are the car's aerodynamic characteristics.
Aerodynamics is a big deal in racing because you want your car to go fast, but stay on the track at the same time. Think about it like this. When a jetliner takes off, it's usually moving between 150 and 180 miles per hour. So, if an Indy car goes over 200 miles per hour, you would think it might take off too, right? Well, one of the major reasons the car sticks to the ground is because of its wings. Yeah, that's right. Indy cars have wings that are similar to a jetliner. But the big difference is the IndyCar wings are turned upside down, providing downforce instead of lift. So, instead of the car taking off like a plane does, the air pressure pushes the car towards the ground, keeping it firmly planted on the track.
So how are race cars' aerodynamic characteristics tested? Well, pretty much the same way we test airplanes, in wind tunnels. A lot of car designers team up with NASA to use NASA wind tunnels to get a better handle on aerodynamics. So whether you're driving in your family car, flying in a plane, or zipping around in an Indy car, it's a good bet that a lot of initial testing was done at NASA. Another NASA-inspired technology being used in racing today is the fire protection suits worn by drivers and pit crews. Originally used by NASA astronauts for the rigors of space, today's drivers wear boots, gloves, masks, and overalls that can help keep them safe in case of a fire. In fact, these suits are so good that recent tests determined that drivers can theoretically survive up to 35 seconds in a fire, with the heat reaching 1,500 degrees. Help us find out about the cutting-edge technology used in these cars. I spoke with my buddy Les McTaggart from the IndyCar Series.
This is a current IndyCar Series car, and I mean, this car is capable of probably traveling over 230 miles an hour at the Indianapolis Motor Speedway, so safety is one of the prime concerns for us, obviously because the drivers are very important. So the whole car, this whole section of the car really is the cockpit area where the driver's located. He sits in this area here. We have a headrest structure around here. This has foam inside, and it's to protect the driver's head in an accident so that this compresses. Behind that we have a molded seat. Now this seat is it's made of a dense foam material, and it's actually molded to the driver's body. It fits every curvature of his body to hold him very securely in the cockpit, so that in a high impact condition he doesn't move in the car, because if he moves in the car, that's when you get an injury.
Let's talk about aerodynamics.
Right, the aerodynamics of these cars actually is really cool, because the whole car is designed like an upside down wing. We propel the air under the car faster than it flows over the top surface, and the reason that we do that is to create ground effects. And the ground effects on this car typically is probably about 3,000 pounds of negative pressure. So you could run this car on the ceiling at 180 miles an hour and it wouldn't fall off.
Wow.
And the idea is so you can go through corners very fast because the car is actually sucked to the ground.
So can you tell the viewers how the aerodynamics have actually changed with the cars?
Yeah, I mean, certainly over the last 10 or 15 years they've become much more sophisticated because we have many more tools to refine the cars. Okay. Wind tunnels have become much more sophisticated in terms of the speeds we can run the cars in. And we can understand all aspects of the cars now, because not only going in a straight line, we look at how they spin, how they react, resistance to the car, and can we improve the safety of the car in different situations. So the tools available to us now are 10 times better than they were 15 years ago. Safety is very important to us, and we're constantly looking at new technology to try and improve the situation for the drivers, because all we can do really is minimize the risk, and anything that we can improve, as I say, we're constantly looking at structures and different mechanisms to make it better.
Drivers have also benefited from other NASA-inspired technology. Things like improved brakes, oil seals, specialized safety seats, accelerometers, and many, many other things. So who are these daredevils that take these risks every day? Well, I caught up with a few drivers to find out how technology is not only helping them drive better, but be safe too.
If you're a race car driver, you're never going to fear that something's going to happen to you. Obviously, it's good to have the safety, but we're always going to be in a risk. It's never going to be 100% safe.
Yellow car in front. Yellow flag, yellow. Great job, Tony.
It makes us more comfortable knowing that we have an extra safety devices. We have the Hunt device, which is it's a device that we put around our necks, and it's attached to the helmet. Because if you had a head crash, your neck wouldn't snap, so you wouldn't break your neck, and then all the other things I talked about. But there's so many variables that can happen on the streets that don't happen here, that I would say I feel a lot safer in the racetrack than actually on the streets.
Now, I mean, we have the seats molded to us. I mean, everything, I mean, it's all really compact. The cars are meant to disintegrate, like, so it takes less G-forces off of us, exactly. So, you know, we still, as drivers, we don't like to even talk about it. But no, it's great. I mean, you know, as long as these cars stay on the ground, that you're safe. So it's come definitely a long way. Sure. Not as far as maybe NASA, but.
All right. So we found out a few technologies that some race car engineers are using that originally came from NASA. But do you think NASA can learn anything from an Indy car? Ha, you better believe it.
Check it out. Right now, NASA is planning missions back to the moon and onto Mars. The capsule NASA will be using is called the Orion. Even though Orion looks similar to the old Apollo capsule, it's a brand new state-of-the-art spacecraft that will hold between 4 and 6 crew members. Now, if you recall, when the old Apollo capsules returned from the moon, they splashed down into the ocean, right? Well, that worked well for the Apollo. But today, NASA scientists are researching whether the Orion will come down in the ocean or if they wanted to come down on land. Either way, some serious work is going into understanding how to protect astronauts from injury during landing.
Although NASA has tons of data on what astronauts may experience during landing, they're also working with IndyCar to look at their data too. This is because IndyCar has detailed data for every crash since 1996. As you can imagine, when a car hits the wall at 200 miles per hour, the occupant will experience huge G-loads. So it's a no-brainer that IndyCar and NASA would be working hand-in-hand to produce better protection strategies for both drivers and astronauts. NASA will use much of the data to help design optimum seat configurations to help minimize risks to our crews upon re-entry and landing, while IndyCar will benefit by having NASA researchers designing seat configurations that may also help keep race drivers safe. So whether in spacecraft or in race cars, both groups are working hard to provide the best protection for vehicle occupants.
Okay, earlier in the show, we talked about how NASA is planning on sending astronauts back to the moon and then on to Mars, remember? All right, well, here's a question for you. Where are they going to live once they get there? And most likely, during the first few missions, astronauts will live on the spacecraft that got them there. But as they begin to stay for longer and longer periods of time, NASA's really going to need to provide some permanent living quarters. So, are we talking condos? Are we talking apartments on the moon? Not quite. What will astronaut housing look like on the moon and Mars? And how will it be constructed? Let me tell you. Right now, the leading candidate for moon and Mars habitats are something called inflatable structures, like these guys right here. Now, these structures are kind of similar to those giant blow-up bounce houses you might find at your state fair or at a birthday party. However, the inflatable structures that NASA's looking at are as tough as nails. They're hard as steel, and they're able to withstand the rigors of space as well as the different environments of Mars and the moon. I spoke with Judith Watson at NASA Langley to find out how these inflatable structures are going to work.
Inflatables have been around for a long time. If you go back as early as the early satellites like the Echo, that was actually a balloon that we orbited all in space. So it was an inflatable structure. As early as the 1960s, Werner von Braun was considering using inflatables on a space station orbiting the Earth. So they've been around for a long time. More recently, in the 90s, we started looking at a possibility of one as part of Space Station to give the astronauts a little bit more room. So it's not that uncommon. It's been around for a while, and now we want to take it and take a look at it. Is it good enough for the astronauts to live in on the moon? We're actually looking at materials like kevlar and vectran, which are very sturdy fabric materials. We use a bladder that's a polyethylene-coated type material, so it's sort of a rubber coating to it to help hold the atmosphere in. Your kevlar, your vectran, which is like webbing, acts as a restraint layer and holds the load. So you have a very sturdy fabric material holding in the atmosphere. Then you put other layers on top of that to protect it thermally from the changes in temperature. It gets quite hot and quite cold on the moon. We also have to look out for radiation problems for the crew. The moon is going to be like living on a vacuum. So you don't have an atmosphere, we don't have air, we have to take that with us. We have the micrometeoroid threat, which means they're small little rocks, varying sizes, that come through very fast at very high speeds, much faster than even a bullet comes through on Earth, that can hit the structure and punch a hole in it. And that's the same whether it's steel, composite, or an inflatable structure. So whatever we put up there, we have to put up a protection layer to protect against that.
Jesus, I have to tell you, I'm dying to touch that. Just to see if I can kind of push it. And can we go over?
Sure,
Should I take a look?
Come on over. It can be as hard as steel. Right now, it's only pressurized like 0.1 psi.
Right.
We want to go to 9 psi. So that's like going from 1 to 100. So it gets a lot stiffer. So if you push on this, you can push on it a little bit.
Yeah, it's a little give to it.
It's a little give. But in reality, once you really bring it up in pressure, the way that it's going to be on the moon, it's going to be as hard as steel. To give you an example of it, here's my trusty basketball. Basketballs are basically inflatables in their own right. They have a certain type of material on them. They're actually even coated with rubber, not unlike that we're going to coat the inside of this guy. And if you think about it, they're pretty darn hard.
They are.
So they can bounce. So it's going to be a very similar principle. We're going to put enough pressure in there that this thing's going to be very hard.
Judith, if I'm an astronaut on the moon, how do I get into an inflatable structure? If it's pressurized, when I walk into it or go into it, isn't it going to affect the pressure?
It will, and that's why we have airlock. So if you want to step around this way, I can show you the airlock and how it operates. Then we can open the door, and you can step inside. And here you go.
Oh, wow, this is amazing. Earlier you were talking about the bladder.
Yes.
Okay. Describe what you mean by the bladder of this structure.
Okay, the bladder's this inside layer. It's coated in polyethylene, which is like a rubber, and that's to keep the air from going out. The idea is we don't want this even leaking a little bit. Anything in space is going to leak a very small amount.
Right.
So we want them to keep their air as long as possible. So we've got that on the inside, and it usually doesn't maintain the structure, the tension that's caused by the air. It's just here to protect the air from going out.
Okay.
So it's a little bit larger, so there we get little wrinkles sometimes if it's not totally inflated like it is right now. It's very stretchable.
Very stretchable.
So that's what the inside is made out of.
All right, Judith, I think we're equalized. We ready to go?
Sure thing.
That is so cool.
I'm so glad you enjoyed it.
Oh.
Very happy to show it to you.
So we know NASA is not just going to send up these inflatable structures to the moon or Mars without testing them first, but where on Earth do you test these structures to make sure they can withstand the rigors of space? NASA packed an inflatable structure habitat and sent it down to McMurdo Station, Antarctica, where the focus was to see how easy it was to deploy and how it held up under those harsh conditions. A small group unpacked and set up the inflatable, then began to inflate it. Once the inflatable was laid out and secured, about 6 minutes later, it was fully inflated and ready to be used. This is good news because although the conditions are tough down in Antarctica, it will probably be just a little bit harder on the moon, where astronauts have to carry their own oxygen and work inside bulky spacesuits. You may wonder if this inflatable structure can actually hold up on the moon and Mars. Why doesn't NASA just send up rigid structures? Well, there are a lot of reasons, but two of the most important are storage and weight. Right now, this huge inflatable structure can fold up into a very small space for shipment to the moon, and it's considerably lighter than rigid structures. Now, this is important. To land 1 pound of supplies on the lunar surface, NASA must launch 125 pounds of hardware and fuel to get it there. Another benefit is that this inflatable structure can be taken down and redeployed multiple times, permitting exploration beyond the initial landing area. So it looks like NASA is on the right track.
Okay, so earlier in the program, we showed you how NASA is working with the Indy car series to help make changes in safety and technology. But they're not the only racing series that NASA is working with. That's right, NASA's also helping NASCAR to help make improvements in their cars, too. Of course, many of the NASA technologies found in IndyCar and in NASCAR are the same. But there are some unique characteristics found in stock car, not found in IndyCar. So what are they? I cruised down to Mooresville, North Carolina to speak with one of the premier teams in all of racing, Team Penske. Can you tell me some things that NASA has been influential with auto racing?
Yeah. In fact, we've got some good applications that we use right here. A lot of them are related to how we protect the driver, keep his head in the game, so to speak. Obviously, one of the byproducts of combustion is carbon monoxide. Bad stuff.
Now, many drivers have complained about headaches, nausea, and dizziness. So, to help these drivers with this type of sickness, Team Penske once again worked with NASA. The solution came from a NASA project called the Low Temperature Oxidation Catalyst that was originally designed for use on space-based atmospheric lasers. So Penske engineers took the basic idea from NASA and then designed a catalytic air filter that removes over 99% of all airborne particles. Once the particles are removed, the air is cooled and pumped into the driver's helmet, giving them fresh, clean air. With this new development, carbon monoxide sickness in drivers may soon be a thing of the past. And this may seem pretty obvious, but one key difference between IndyCar and NASCAR is that NASCAR vehicles have a roof. So why is this so important? Well, one big factor is heat. In an IndyCar, the driver is exposed to a 200-mile-per-hour wind stream, which keeps them relatively cool. But in a stock car, the roof keeps a lot of the heat inside, allowing temperatures to reach upwards of 160 degrees. To combat this, NASCAR teams began insulating car cockpits with the same type of thermal protection system that protects the space shuttle when it re-enters the Earth's atmosphere. This addition only added 4 pounds to the car, but cut the heat inside by over 50 degrees.
We're always questioning the design. First thing is, we have what's called a scale model program. We have a car just like this, but it's 45% of that in every detail. We'll blow that and do design studies on that to figure out, how things work.
Right.
Second thing is, we'll take these full cars and we'll blow them in a wind tunnel.
Sure.
We've done it at Langley.
NASA wind tunnel.
There you go.
Langley.
Another way is purely theoretical, to use computational fluid dynamics to look at the flow of the car, which is all mathematical. If you take all of those approaches and combine them, you start to get a full understanding of what's going on and how to make it happen.
Doctor, what inspired you to become an engineer?
Well, NASA had a huge role in it. I grew up in that community, watched all the moon launches from my front yard, so it was just a part of that culture. And science and technology and engineering as applied science, it was a natural for me. So I couldn't say no. Haven't regretted it since.
Ken, thanks so much for having us down here at Penske Racing.
No problem.
Definitely, and we'll be seeing you at the next race.
Enjoyed it.
Take care. So we have learned a lot today about exploration and how NASA technologies are helping out in auto racing. And with us going back to the moon and on to Mars, there's no doubt that tons of these NASA technologies will be converted to be used in our everyday lives. Yeah. Jennifer Pulley, I'm Johnny Alonso. Catch you next time on NASA 360.
To cutting edge.
What about the most
And how NASA technologies are helping out. Again?
Dozens of national... Yeah. Right. Okay. So what is that?
Ken, thanks for having me down here at Penske Racing.
No problem.
And we'll be rooting for you too. Do it again. Ken, thanks so much for having us down here at Penske Racing.
No problem. Come back anytime. Enjoyed it.
Definitely. And we'll be voting for you. Jeez, I can't get this done. You're moving the card, I'm moving out. Voting, rooting.
or actually can be found?
So to find out what some more of these NASA-inspired technologies are, I came here. Ah, that was it. Driving in a family car, zipping around in an Indy car. Sure bet that, whatever, the last line.